Alright, Trig, we're doing section 9.8. And in section 9.8, hold on just a minute, we are finding sums and differences off screen. Oh, no. Of odd powers. Okay. This particular section was featured on the television show Fairly Odd Parents, for those of you who are fans. Anyway, so x cubed minus 125 equals 0. We want to find all the complex solutions to this. There is one real solution, but the other two solutions are imaginary or complex numbers. So the first thing I would want to do is I would want to graph x cubed minus 125, and then we'll get to see one solution right on the screen. So we're going to graph that, and zoom 6 is going to shows me where it crosses the graph. Now I'm going to go ahead and calculate a 0, right, just like we've done before. Left bound looks like -4 would be a good left bound. Sorry, technical difficulty. Alright, we're back. Anyway, so our left bound was -4, and our right bound, what? Why'd I choose -4, Mr. Staley? That's pretty ridiculous. But it still is on the left side, nonetheless, even though I'm pretty much an idiot. Looks like +6 or 7 would be a good right bound, so I'll put that over there. My goodness, that's a wide window. But okay, it's got to find a 0 in between those. I'm sure it's able to do that. I don't want to guess, so I'm just going to hit the enter button right now. And it goes and finds it at 5. That makes a whole lot of sense because 5 to the third power is 125. Okay. So now we could use synthetic division to find a quadratic, and then either factor it or use the quadratic formula. So 5, we've got a cubic term, no quadratic term, no linear term, and a constant. Right, good old synthetic division, carry down the 1, multiply, and add, multiply, and add, multiply, and add. Wait, that's great. We got 0 for a remainder. That must mean it's a factor. Yes, it does. So now we can either continue to factor this. We can't factor that. X squared plus 5x plus 25. I don't know any factors of 25 that add up to 5. I better use the quadratic formula. X equals the opposite of b, plus or minus the square root of b squared minus 4 times a times c all over 2 times a. No, I'm not going to sing a ridiculous song. To Pop Goes the Weasel. Maybe we should make up our own rap song. That would be better, something more vital to the times, that kind of thing. So let's see here. My discriminant, 25 minus 100. Whoops, okay, that's not too hard. So -5 plus or minus the square root of -75 all over 2. A little bit more simplifying. I've got that's square root -25 square root 3. Okay. So this would be -5 plus or minus 5i radical 3 all over 2. Hey, complex conjugates right there, folks. We know that from the complex conjugate formula, or theorem, I should say, which says that the complex solutions come in conjugate pairs. Talked about that last year in Algebra 2. Well, we could be doing this each time, or we could expand this idea to a theorem. I know this is going to look nasty, ugly, and gross to many of you. Sums and differences of odd powers theorem. We can actually break this down. The original quadratic or cubic could have been broken down into a linear factor and the rest of it. So in other words, when we found out that 5 was a solution, that should have been made sense, that x minus 5 would be a factor. Well, that makes a whole lot of sense, right? That goes into that. And what we were left over with was x squared plus 5x plus 25. Now, is there a way to be able to look at that and factor it without having to find a real zero on the calculator, go, do synthetic division? And the answer is yes, there is. So let's look at this sums and differences of odd powers theorem. The first thing you want to do if you're trying to break something down with an odd power is you want to take that odd root. So if it was a fifth power, you take a fifth root. If it was a seventh power, you take a seventh root. But that'll get you your linear factors. That's the easy part. It's the rest of this junk that kind of looks a little hairy. First of all, there's no Pascal's triangle involved. But the second part kind of reminds me of Pascal's triangle, right? So no Pascal's triangle, but then you have, since you took a linear factor out of the term, this one will always start out being one smaller. So if it was a fifth degree, this exponent would be a 4. And you'll notice how it's decreasing. Just like we did when we were expanding Pascal's triangle, doing those binomial expansions. Okay, and then once we got down to x to the 0 power, we would drop down. Once again, this one would be, 1 less than the power that we were dealing with in the beginning. And you would count your way down, just like we did before with expanding Pascal's triangle, until we got to y to the 0. Now, the reason I wrote these things out is because I'm going to multiply these two things together, and that's going to go inside my parentheses. I'll multiply these together, put that inside my parentheses. Multiply these together, put them inside my parentheses. Okay? Now, you'll also take note that the signs alternate starting and ending positive. So this one over here is positive, and the last one's positive, and they just alternate back and forth, minus, plus, all the way through. That is not going to be true when we get down to the next part. The next part, we're talking about the difference of odd powers. We still do the same thing. Take the nth root to find your linear term. And it's always the same sign as what you have there. In both cases, it's the same sign. Now this is going to look exactly the same as it does up there, except for one difference. All of the signs are positive inside here. So when you're doing the difference of odd powers, every sign in the second set of parentheses is going to be positive. Okay, let's do a couple examples. So we have a sum of odd powers. Now I know you're saying to yourself, okay, well that looks like an even power. Well, it happens to be the multiple of an odd power. So if we take the cube root of both of these, we're going to get 2a and 3b squared. And the same sign comes down in between. So we got the linear part one taken care of. Okay, so over here, since I took out 2a, I'm left with 2a squared, 2a to the first, 2a to the 0. Since I took out, so really what I had here was 3b squared to the third. That's really what I was dealing with. So 3b squared, oops, sorry, put my parenthesis in the wrong spot, squared, 3b squared to the first, 3b squared to the 0. Now, multiply everything up into your parenthesis. So that's 4a squared. This is 2 to the first and 3 to the first, so that's 6. Oops. A and b squared. And this is 3 squared, which is 9. And b squared squared would be b to the 4th, because you multiply the exponents together. Because I was dealing with a plus, these will alternate signs. So positive, negative, positive. It always starts and ends with a positive. That's it right there, folks. Okay? It'll probably say something like factor on those questions. So factor a to the 5th plus b to the 5th. Okay? Alright, so a plus b, right? We take the 5th power of both of those. We have a to the 4th and a to the 3rd and a to the 2nd, a to the 1st and a to the 0. And b to the 4th and b to the 3rd and b to the 2nd and b to the 1st and b to the 0. And so we multiply them together, and this is pretty easy. And because it's plus, they alternate signs. Okay, so what about this one? Well, first, this one doesn't look like it's a difference of odd powers. It looks like a difference of even powers, which it could be thought of in that way, but it could be also thought of as x squared to the 3rd power minus 2 squared to the 3rd power. I guess you could have said 4. I'm kind of dumb about that. That should have been a 4. So we take our cube roots, and we get x squared and a minus 4. Oh, look, a difference of perfect squares. How cute. So this could be broken down even farther. Yeah, x plus 2x minus 2. Whew, hold on to that little trick. Oh, man, I didn't leave myself a whole lot of room here. Okay, so if I took out one of the cubes, then I'm left with x squared squared, x squared to the 1st, x squared to the 0. 4 squared, 4 to the 1st, and 4 to the 0. And I multiply them together, right? X squared squared is x to the 4th, and 4x squared, and 16. And because that's a minus, all of these are addition. So my final answer is going to be x plus 2 and x minus 2, and x to the 4th plus 4x squared plus 16. Now this next theorem I'm going to put up here on screen, I don't want any of you to write down that are actually listening to my voice. This is for all those people who out there ignoring me, but they're looking at the screen right now. Remember, those people need to learn a lesson. Okay? And don't help them out, folks. make sure that they write all this stuff down. This is the sum and differences of cubes theorem. Now, for those of us that understand the sums and differences of odd powers, takes this and does this exact same thing. This is a special case. So we talked about this last year in Algebra 2, the sums and differences of odd powers. So I'm just going to move my pen here so that it looks like I'm saying something important, but really I'm not, because this particular theorem is included in the last one. So if you know how to do it with fifth powers and seventh powers, you can easily do it with third powers, okay? But for those people who are at home, who are just looking at the screen and writing everything down that appears on screen because they don't want to listen to my voice, then this part of the notes is for those people. Thank you. Have a great day.